All right, here's a couple of naming questions from the worksheet. The first one is silver bicarbonate. And bicarbonate, I would think that it would be in the chart down here. But you look and there's no bicarbonate. I see carbonate and hydrogen carbonate. Well, actually, bicarbonate and hydrogen carbonate are the same, just named different. So this one, I probably should have written it as silver hydrogen carbonate. And if it's silver hydrogen carbonate, then silver has a positive charge. Hydrogen carbonate has a 1 minus charge. So the charges are even. So I can just write the compound as AgHCO3, just like that. Okay, the one down below there, number 18, oxalate. I look over on my chart here, oxalate right there. So OOCCOO, and it's a 2 minus. So OOCCOO, 2 minus. And copper, right here, they're saying copper is one of those ones that has 2 charges. And they're saying it's using the 2 plus charge. So I put a 2 plus here. Charges are even, and so I can just write it as CuOOCCOO. Now, some books sometimes, rather than writing all the oxygens out like that and all the carbons, they group them. So you might see this as CuC2O4, but I prefer writing it out like this because chemically, and you'll see that in Chem 30, this is a better indication of what the compound looks like. But you could write it like that too. A couple other ones, tungsten oxide. So I have to look for tungsten. I think it's W. Where's tungsten? Uh-oh. Things are on top of each other there. There's tungsten right there. So tungsten right there has a 6 plus charge to it. So where's my tungsten? So tungsten has a 6 plus, and oxygen, so oxide or oxygen has a 2 minus charge. So if I need to balance those charges, I'd need to add a couple more oxygens. So altogether I have 1 tungsten and I have 3 oxygens. So that'll be the formula for tungsten oxide. Okay, and then the last 2 questions had to deal with acids. So the rule is if you were to name it not an acid, if it ended in an 8, then it's something ic acid, like hydrochloric acid. If it ends in an ite, then it's something like chlorous acid. If it ends in an ide, then it has to be hydro and then ic acid, like hydrochloric acid. So I need to look at what I have here. So HClO2. So HClO2, ClO2 is in my chart here. It looks like it's, where is it? It's chlorite. ClO2 is chlorite. Okay, so this one would be hydrogen chlorite. Okay, ite, not ide, ite. So I look at my rule, here's the ite right there. So what I do is I just call it us acid. I don't put a hydro in there, I just leave it like that. So that would be chlorous acid. And similar to the next one this is chlorate. So an ionic name, you could call it hydrogen chlorate. But chlorate goes to just ic acid, no hydro in front of it, just ic acid. So that would be chloric acid. Now just to show the other one, if it was like this, HCl, then an ionic name would be hydrogen chloride. And since it ends in an ide, it'd be this one, right? So I have to put a hydro first. Hydro. And I'm spelling that wrong. That's an R. That's why I have an eraser. So I have to put a hydro, and then chloric acid. Okay? So if there's a hydro, it must have come in from an ide right here. Okay, so like this one, I guess this one, no, not that one. This one here and this one here, put in a hydro means it's HCl. But if there's no hydro, if it's just chloric acid, then it must have come from one of those complex ions that are in this chart here. All right, hopefully that helps you with those few questions.